Polynomials using long division and synthetic division. This is actually section 4.3. Write that down for you. 4.3 from our book. I'd like to start with this. Dividing polynomials using long division is very similar to dividing your basic numbers using long division. So I would like you to do this without a calculator. Pause your video, and when you're done, press play and I will display the answer. Here we are. You'll notice we ask ourselves, how many times does 5 go into 6? The answer to that question is 1. We multiply 1 times 5, put 5 underneath, subtract that from 6, get 1, carry down the 3, and then the process repeats all the way up until we have 1 here, and that's a remainder. And the remainder goes up to the numerator, and then that is 1/5. So 1,265 1/5 should be your answer. Now that we've done that, let's take a look at this polynomial here. And all the while I'm dividing this, I'm going to be referencing when we divided using just numbers. So the first step is to write this like a long division problem. We have x to the 4th plus 2x squared plus 1. But there's a problem here because I need to put some placeholders in. So I'm going to erase this. We are going to include in all the 0 coefficients that are in our numerator. So I have x to the 4th plus 0 x to the 3rd plus 2x squared plus 0x plus 1. This all is going to get divided by x squared plus x minus 3. Oops. Try again here. Minus 3. Again, it's really important to leave these placeholders in for our 0 coefficients. So, just like we did over here with the long division and the numbers, we said how many times does 5 go into 6? Over here, we're going to say how many times does x squared go into x to the 4th? And the answer to that question is x squared times. So I'm going to put my x squared up here. And just like we did over here, we took our 1 and we multiplied by the 5. Now we're going to take x squared and multiply by x squared plus x minus 3. When we do that, we get x to the 4th plus x cubed minus 3x squared. Now when we did our long division, we subtracted. When we do polynomial division, we are going to subtract as well. But the easiest way not to make a mistake is to change the signs and add. So this now becomes, I'm going to do this in a different color. This is a minus. This is now a minus. And this is a plus. So we'll add straight down. The x to the 4ths cancel out. And I end up with minus x to the 3rd plus 5x squared. Now we're going to bring down 0x, just like we did over here. We brought down the 3, we're bringing down the next term, 0x. And again, over here we said how many times does 5 go into 13? Now we're going to say how many times does x squared plus x minus 3 go into minus x cubed plus 5x squared plus 0x. And the best thing to do is just to look at the leading coefficient. Ask yourself, how many times does x squared go into minus x to the 3rd? And the answer to that question is minus x. Again, we're going to multiply through, so that would give me x to the 3rd, minus x to the 3rd, minus x squared plus 3x. And you can see why these 0 placeholders are so important, because up here I wouldn't have been able to add my like terms together, and same thing over here. So now again we're going to subtract, so we're going to change the signs and add. And this one here becomes a negative. And we'll add through. The x to the thirds cancel out. I end up with 6x squared minus 3x. And now again, we're going to bring down the 1, and we're going to repeat the process. How many times does x squared go into 6x squared? That's 6 times. And we'll multiply it through. That gives me 6x squared plus 6x minus 18. Again, change the signs and add. This is now minus, this is also minus, and this is plus. And now we'll add straight down. The 6x squareds go away. I'm left with minus 9x plus 19, and that's our remainder. And I'm going to make all this a little bit smaller because I now have run out of room. And over here we wrote our remainder is 1 over 5. Over in our new problem, we are going to write our remainder is plus minus 9x plus 19 over x squared plus x minus 3. And this is the answer to that long division problem. Now I'd like to have you guys give this one a try. Write it down in long division form. Try to follow the same process. And right now press pause, and then when you're done, press play and you'll see the answer. And here's what you should have gotten. And if you got something different, check your work. I have all my work shown here for you to see. Here's another division problem. Give this one a try. Pause the video. When you're ready, unpause it and take a look and see if you got the answer correct. And here is the answer and all my work, and hopefully got the same thing. And you'll notice that there is 0 as a remainder. What do you think that means? Did you guess? It means that 2x plus 1 must be a factor of 2x cubed minus 9x squared plus 7x plus 6. Isn't that cool? Now, again, I'd like you to divide. When you're ready, press play and see if you got the right answer. And here's my solution. If you did not get the correct answer, press pause, take a look, see if you can't find your mistake. And let's see, I noticed one thing on here. There's a plus 6 as a remainder. I would have written this as plus 6 over x plus 1. Now I'd like to show you a different method for dividing. When you are using long division and you are dividing by a linear form, like either x minus a number or x plus a number, you can use something called synthetic division. And it's actually quite efficient and goes very quickly. But you can only do it when you're dividing by a linear factor. So I'm going to display the problem that we just did, and I'm going to show you how to use synthetic division and how it relates. You'll notice we're dividing here by a linear factor, x plus 1. So I'm going to write minus 1 here. We get minus 1 by setting x plus 1 equal to 0. That gives me my x equals minus 1. So minus 1 is going to go up in the corner, and then I'm going to write the coefficients of what I'm trying to divide. So that would be 1, that's in front of the x to the 4th, minus 1, that's in front of the x cubed, 0, that's in front of x squared, minus 2, and positive 2. Process for synthetic division goes like this. And one thing you have to be certain of is that you put those placeholders in for the 0 coefficients, just like I did here. First thing that I do is I'm going to take this 1 and I'm going to add straight down. There's nothing here to add to 1, so it just becomes 1. Then I'm going to take 1 and multiply by negative 1, and that gives me negative 1. Then we're going to add again. That's negative 2. Multiply the negative 2 and the negative 1. That's positive 2. Again, add straight down. 2 times negative 1 is negative 2. Add straight down. Negative 4. Negative 4 times negative 1 is positive 4. 6. This is my remainder, and these are all the coefficients of my answer. And you can see that it matches up there. So I'm going to write my answer. It is going to be 1 degree less than what I was dividing. So I have the x to the 4th here. My answer is going to be 1 degree less, x to the 3rd, minus 2x squared plus 2x minus 4. And then again, it's a remainder 6, so I would write it as plus 6 over x plus 1. So that's the procedure. You put the potential 0 of your factor in the upper left-hand corner. You write your coefficients of what's underneath your division sign, and then you add down, and then whatever your result is, you multiply it by what's in the corner, goes over the next number here, and again add down and keep repeating. And then your result are going to be the coefficients of your solution or your quotient. Now I want you to give this one a try. When you're ready to see the answer, press play and we will check your work. And here's the solution. Oh, it's not showing up all the way here. Let's give it a from there. I think that did it. And hopefully got it right. If not, press pause and check your work. That concludes our lesson for today. Refer to my website for the assignment. Have a nice day.